Music exists in every recorded human culture. Its presence across every isolated society suggests it is a biological constant rather than a cultural invention. We recognize that certain melodies help us focus or drive us to march in step, yet we often categorize these reactions as subjective emotional responses. The ODTOE framework proposes that music is a structured external configuration designed for interfacing with human biology. This configuration interacts with the listener's internal coherence apparatus, their B profile. What we feel as a shift in mood is the biological coherence being modulated, moving the observer into a different state. This interface operates through three distinct mathematical channels: pitch, rhythm, and timbre. Pitch acts on emotional coherence. Consonant intervals, like octaves and fifths, use mathematical ratios that align with our internal harmonic structure, effectively raising the listener's state. Rhythm addresses internal contradiction. A predictable, steady tempo provides a reliable structural anchor, which lowers cognitive stress and stabilizes the observer. Finally, timbre provides empirical reinforcement. As we see here with a full orchestra, a high density of spectral information provides the brain with a massive amount of experiential data to anchor to. Because these three channels are measurable, specific musical structures correspond to observable changes in the listener's internal coherence. This raises a question of diversity. If the biological hardware is universal, why does every culture use a different musical tuning system? While the structural function of the interface is universal, the specific protocol is determined by cultural calibration. A listener trained on Western 12-tone math might hear a traditional interval as flat, while someone trained on the bronze resonance of a gamelan ensemble would hear Western scales as incorrectly tuned. These observers are simply calibrated to different internal ratios. Our perception of a pure note is a product of how our culture has programmed our internal coherence profile. Yet, certain works maintain their structural integrity across these cultural boundaries. This happens when the architecture of a piece follows phi, the golden ratio. Historical masters like Claude Debussy created works that exhibit this exact mathematical proportionality in their movement structures. Following these proportions minimizes cognitive overhead. The brain processes the music using the same minimum information growth laws found in plants and physics. These works are optimized for the processing limits of the human mind. When hundreds of minds share the same acoustic configuration simultaneously, the scale of the effect changes. Individual profiles begin to align under a shared sound. This B-locking effect means the collective coherence of the crowd becomes greater than the sum of its parts. This synchronization allows large groups to move with a single focus, as seen in the strict physical coordination of marching soldiers. It also provides an internal alignment, using sound to synchronize the emotional state of a collective during deep ritual chanting. In many traditions, sound acts as the driver for physical output, allowing a group to labor as a single unit. These ancient practices serve as coherence-locking technologies deployed for thousands of years to synchronize human activity. We can use these same principles individually, applying specific pitches for sustained focus or frequency-rich sound to aid biological recovery. DJs and event planners instinctively use these musical profiles to dictate the collective state of a room. This biological integration shows that music serves as a fundamental tool for social and cognitive synchronization. When we put on headphones, we are actively engaging an interface that tunes the fundamental coherence of our internal reality.